Welcome to part 2 of solving linear systems algebraically. In this episode, we'll be doing application problems, your favorite word problems. So let's take a look. First word problem. An artist is going to sell 2 sizes of prints at an art fair. The artist will charge $20 for a small print and $45 for a large print. The artist would like to sell twice as many small prints as large prints. The booth the artist is renting for the day costs $510. How many of each size print must the artist sell in order to break even at the fair? Okay, so here I have the first thing I do when I'm starting a word problem is I want to identify my variables. And I know this is going to be a system of linear equations because I have 2 different things I'm looking for. Usually the last sentence tells me exactly what I need to find. How many of each size print must the artist sell in order to break even? So I need to figure out the quantity of the 2 different sizes. So let's go ahead and define our variable. The first variable is going to be for my small prints. So S, I'll use the variable S, and it'll be the number of small prints sold. Okay, because remember in the question it says how many of each size, so our variable has to stand for quantity. My second variable is large, and on this L kind of looks like a 1, so instead I'll use G for grande, and then we'll do the number of large prints sold. So now that I've defined my 2 variables, I'm going to take a look at my sentences. These are what deal with quantity, and in here I have some money. So let's take a look at what the money values I have. It says the artist will charge $20 for a small, $45 for a large. And then finally it says the booth the artist is renting costs $510 a day. So all of these have to do with money. Okay? The other sentence says the artist would like to sell twice as many small prints as large prints. And that has to do with quantity. So usually when I have something that deals with money and something else that deals with quantity, those are going to be 2 separate equations. This wants to know how much I have to do to sell it in order to break even. So let's write the first equation dealing with money. So if $20 is the cost of a small print, I can multiply 20 times S, the number of small prints sold. Then I would add that to the number of large prints sold, multiply by that cost. $45 times multiplied by the number of large prints sold. I need this to equal $510 just so I can break even. So here's my first equation dealing with quantity. Here's my first equation dealing with cost. My second equation is going to deal with quantity. The artist would like to sell twice as many small prints as large prints. This one is a little tricky. We have to think about it a lot. I like to think of a real example. So if I want to sell twice as many small prints as large prints, if I sell 4 large prints, I need to sell 8 small prints to have twice as many. So that means I'm multiplying 2 times the number of large prints in order to get the total number of small prints sold. So here my equation becomes 2G is equal to S. Now that I've written my equation, now that I've written both of my equations, I want to go ahead and figure out how to solve this. I can use elimination or substitution. It doesn't really matter. But I really think that this system really lends well to substitution. Here I'm already solved for S, so I can just take 2G and plug it into S of my other equation. And that's what I'm going to do to solve. So I'd rewrite that down here as 20 times 2G plus 45G is equal to 510. And then I multiply, I get 40G plus 45G is equal to 510. Add these quantities together, and I'm going to get 85G is equal to 510. And then I'm going to divide by 85. So then I find that my G is equal to 6. So that means I've sold 6 large prints. But now I need to figure out how many small prints I sold. So I need to plug G back into one of these equations. I'm going to choose the second equation because it's much easier. 2 times 6 then must equal S, the number of small prints. So 12 equals S, the number of small prints sold. So now I can go ahead and write my answer down. I can say that I have sold 12 small prints and 6 large. And that is my answer. Now you may want to check your answer as well to make sure that you did it correctly, and I think that's always a great idea. So even though I plugged it in here, I might want to go back and check that that's correct by plugging in 6 or 12 for S and 6 for G, and making sure that that equals 510. Okay, now it's your turn to try. Take a look at the problem here and see if you can, number 1, define your variables, number 2, write a system of linear equations, and then 3, solve, either using a substitution or elimination. Did you get the right answer? Take a minute to pause the video and check your work. I chose to use substitution in this problem, but if you chose elimination, either one would work. Okay, let's take another look at another type of problem. Here we have a farmer owns chickens and pigs. If a farmer counted 17 heads and 60 legs, how many total chickens and pigs are there? So again, I want to define my variables first, and I'm going to look at the last sentence. And here, right after the comma, it asks me, how many total chickens and pigs are there? So I'm going to go ahead and define my variables. Well, chickens and pigs, and I need to know quantity. So I'm going to say that C is my number of chickens. And P is going to be my number of pigs. I need to go back then and look and see at the information I'm giving me. I don't have a lot of information here. Here, the only thing I have is that there's 17 heads and 60 legs. So I need to understand some things about chickens and pigs. Well, heads. How many heads does a chicken have and how many heads does a pig have? Well, they each only have one head. So I need that the total number of chickens and pigs is actually 17. So I can say that my first equation then would be the number of chickens, C, plus the number of pigs, P, is going to equal 17. Then I says I have 60 legs. Well, then I want to think about how many legs does a chicken have and how many legs does a pig have. A chicken has 2 legs, so I could say 2 times the number of chickens, because each chicken has 2 legs, plus 4 legs for a pig, so 4 times P is going to equal 60, the total number of legs counted. Now that I have my 2 equations set up, I can go ahead and choose either elimination or substitution to solve this problem. I would say both elimination and substitution are equally easy to do in this problem, but I'm going to go ahead and do elimination since I did substitution on the last problem. So in order to do elimination, I need to have coefficients of my variables that are either opposite or the same. And I tend to like mine to do opposite. I'm going to go ahead and eliminate my C because I can easily multiply anything by 2. So I'm going to multiply the top equation by a negative 2. I'll use a different color here. When I do that, I'll get negative 2C minus 2P is equal to a negative, well, 15 and 15, that's 30, plus the extra 2 is 34. Then I'm going to rewrite my other equation right below because I automatically have now opposite coefficients. Because my coefficients are opposite, then I'm going to go ahead and add my two equations together. Negative 2 and 2c, they cancel out. Negative 2p and 4p, that gives me a positive 2p. Negative 34 and 60, if I add that together, I get a positive 26. And then if I divide both sides by 2, I'm going to find that p is equal to 13. So there are 13 pigs. In order to figure out how many chickens there are, I need to plug p back into one of my original equations. I'm going to go ahead and choose the first one just because that one seems to be easy to plug into. C plus p is equal to 17. If I plug in 13 for p, I need to solve for c by subtracting 13 from both sides. Then I find that c is 4. So on the farm, I know there are 13 pigs and 4 chickens. I can always double check my answer as well by plugging 13 and 4 into the opposite equation, 2c plus 4p equals 60, to double check that my answer is correct. Okay, one more for you to try. Take a look at the next problem. Take a second to write out your variables, write your system of equations, and solve. Then check your answer. I also did this equation by elimination. Again, you can be using elimination or substitution, but generally when we get a little more complicated equations, most people kind of gravitate towards elimination. If you have any questions on writing and solving a system of linear equations for a word problem, please come and see me. We'll also do some more practice in class tomorrow. Have a great night.